Assistant Professor Physics in the Department of Physics, Maharaja Jivaji Rao Shinde College, Srigonda, Ahmednagar. We have started our syllabus related to network theorems and we have completed what is Thevenin's theorem. Today we are going to see one more theorem, that is Norton theorem. Norton theorem is similar to Thevenin's theorem, but only instead of voltage source we will replace all the sources and resistances in the complicated circuit by a constant current source and a resistance in parallel to it, and that structure or that circuit is nothing but the Norton circuit. What is Norton theorem? Norton theorem, in Norton theorem we will have a network. We will have a network which is two terminal network or a linear network, and it consists of combination of sources and resistors. Now we will replace this network by a circuit which will have only two components, and one of the component is constant current source, and this is represented by iron, and there will be one resistance which will be in parallel to constant current source. This is the Thevenin's equivalent circuit of this network. Same is represented here. It means that we have considered a network which is having two terminals A and B. It consists of a voltage source E, resistances R1 and R2, and there is one load which is across A and B terminals of the circuit. This is a normal circuit, and now we will replace this R1, R2 and E, that is EMF source, by a single constant current source IN and a single resistance Rn, which are parallel to each other. And now in its circuit, extended circuit, there is a load. Now we have to calculate the current through load. In case of Norton theorem, the value of iron is nothing but the short circuit current. Value of iron is nothing but the short circuit current across A and B. Short circuit current across terminals A and B. These are the terminals. And what will be the value of Rn? The value of Rn will be the same, similar that we have utilized in case of Thevenin's theorem. That is, value of Rn is obtained by removing all the sources in the circuit by their internal resistances. So second part will remain same. Only we have to replace the first part by iron. V will be replaced by iron, and there they will be they were in series. Now here they are in parallel. So Rn value is nothing but remove all the sources by their equivalent, by their internal resistances. And this circuit is called as equivalent circuit or the equivalent Norton circuit or the Norton equivalent circuit of this network. Now students, we will see how to Nortonize the given circuit, means how to convert a complicated circuit into its Norton equivalent circuit. That process is called as Nortonizing the given circuit. Now students, we will see how to Nortonize the given circuit. When we want to Nortonize the given circuit, means convert a given complicated circuit into its Thevenin's equivalent circuit, then what we have to do? We have to replace the sources, that is E, and the resistances in a complicated circuit by their Thevenin by their Norton current, which is short circuit current, and a Norton resistance or the equivalent resistance Rn. Now the condition for Rn is that this ion is nothing but the short circuit current across A and B, as our circuit is having two terminals, and this value of Rn is obtained in the similar way as we have obtained value of Rth in case of Thevenin's theorem. So value of Rn can be obtained by value of Rn is obtained by removing all the sources by their internal resistances, and like that there will be the parallel circuit. Iron will be parallel to Rn, and this is nothing but the Norton equivalent of a given circuit. So we will start to Nortonize the given circuit. Here circuit is given where E is equal to 10 volt. Here one resistance is given as 4 ohm. Here another resistance is given as 6 ohm, and the load is given as 5 ohm. This load is across A and B terminals. So the first step is what we have to do. We have to remove this load. So in order to remove this load, when we remove this load, then this circuit will becomes like this. It means that this is the two terminals A and B, and as we have removed this load, this becomes a short circuit. In case of short circuit, a current ISC, that is short circuit current, will start to move across A and B. So when we remove this load resistance, then as 6 ohm and this load resistance, they are in parallel, it also get removed. So in our circuit there are only two components left. First one is the 10 volt source and 4 volt resistance. So how to get the current across 6 volt resistor? So in order to get a current across 6 volt resistor, what we have to do, that is ISC is given by, what is value of I? V upon R. So here value of V is 10 divided by R 4, and its value comes out as 2.5 ampere. This is the value of ISC, and as it is a short circuit current, it represents our Norton equivalent current, ISC. It means that after this, now what we have to find out? We have found out this. Now what we have to do? We have to find out the value of Rn. Just now we have seen that in order to find out value of Rn, we have to remove all the sources, and so what we do? So we will remove this 10 volt, and when we remove this 10 volt source, then we have to represent this 10 volt by its internal resistance. But as in case of this 10 volt source, internal resistance is 0, so we will not consider it here, and hence our circuit gets simplified in this way. Now if we look at the circuit from this Rn side or AB side, then this 4 ohm and 6 ohm resistances, they are parallel to each other. It means that 4 ohm resistance and 6 ohm resistance, they are parallel to each other, and therefore their resultant or the equivalent resistance Rn can be given as R1 R2 divided by R1 plus R2. If this value is R1 and this value is R2, then this will be the value of Rn. Substitute value of R1. R1 is 4 into value of R2, 6 divided by R1 R2. 6 plus 4. Therefore this value comes out as 24 divided by 10 is equal to 2.4 ohm. It means that Rn value that we have obtained is 2.4 ohm, and this is nothing but the equivalent resistance of Norton theorem or Norton equivalent resistance of a circuit. So we have found out both the values. We have found out its equivalent current and also equivalent resistance. So what we do, we will substitute or we will replace this source and these two resistances by a current source, constant current source having value 2.5 ampere and a resistance which is called as equivalent resistance having value 2.4 ohm, and this resistance is parallel to constant current source, and this is nothing but Norton equivalent circuit of this part. Now last step is that we have to calculate the current passing through this load resistance. In order to calculate, now we have to calculate the current passing through this load resistance. Now this is the equivalent circuit and this is the load across A and B. Now we want to calculate the value of IL. What will be the value of IL? IL is nothing but IN into Rn divided by Rn plus RL. What is the formula to calculate IL? IL is equal to IN equivalent current into equivalent resistance divided by Rn plus RL. Now substitute the value of Rn. IN value is nothing but this ISC. This is ISC. IN. Norton equivalent value. Its value is 2.5 into Rn. Just now we have calculated the value of Rn and its value is 2.4 ohm divided by Rn plus Rn. What is the value of Rn? 2.4 plus 2. Value of RL. RL value is 5 ohm and RL value is 2. And this gives us value of IL as 0.81 angstrom. So let's revise the things once again. In order to Nortonize the given circuit, what we do, initially we have removed this RL. After removing this IL, we have short circuited the AB terminals and that current is named as ISC, short circuit current. It is equivalent to Norton current. So its value is found out by substituting the values of V and R in the formula V by R, as this RL and this resistance, they are parallel. It also get removed. So in circuit we will have only 10 volt source and a resistor. We have substituted their values and found out the value of IN. Now we have to find out the value of Rn. And in order to find out the value of Rn, we have to remove the source and replace it by its internal resistance. As the internal resistance value is 0, we will have only these two components in the circuit. And now they are parallel to each other. And hence Rn value is nothing but R1 R2 divided by R1 plus R2. And we have obtained its value as 2.4 ohm. Now we will replace or represent this structure by its Norton equivalent circuit, which will have IN value as 2.5 ampere and Rn is parallel to IN and its value is 2.4 ohm. Now last part remains to calculate the current passing through RL. In order to calculate the current passing through RL, we have one formula, that is IL current is equal to IN constant current into Rn divided by Rn plus RL, and by using this formula and substituting the values of IN, Rn